Good morning, Grade 7s, and welcome to WorksheetCloud Grade 7 Natural Sciences. For those of you who don't know me, and this is your first time joining us, welcome. We look forward to having you. If you have a question during the lesson, please send an email with your question to grade7@worksheetcloud.com. Right, let's get started. Today's lesson is on different types of energy, and as you know, I am Mrs. Hall, your Grade 7 Natural Science teacher. So, today's objectives, Grade 7s, is to list the different types of energy, to describe the energy store before and after a change, and the energy transfers involved, and to state and explain what is meant by conservation of energy. I hope you enjoy this lesson and you learn something new today. So, let's get started with heat, or alternatively known as thermal energy. So, anything with a temperature above absolute zero has heat energy. That means everything has some heat energy. The hotter something is, the more heat it has. Right, kinetic energy, you've learned about already. It is anything that moves. It has kinetic energy. We went into a lot of detail about kinetic energy and movement, which is movement energy, as well as the different types of potential energy. Okay. So, nuclear energy is released only from nuclear reactions. Example, the sun and all of the stars. I hope you enjoyed my little video clip on A Star is Made. That was such a beautiful little video. If you didn't, please go back and watch it. It was one of my energy lessons. Okay, so the sun and all the stars, the hydrogen bomb through fusion, nuclear power plants, and the atomic bomb through nuclear fission. Okay. Sound energy, anything noisy gives off sound energy, like your vocal cords, and hopefully you recognize some of these amazing singers up here. Okay. Speakers, like over here, as well as musical instruments. It gives you sound energy. Light energy is anything that is luminous. It gives off light energy, like the sun, light bulbs, candles, and yes, even little glowworms. So, chemical energy, grade 6s. We did discuss it as part of our potential energy. It is stored energy. It is anything with stored energy which can be released by a chemical reaction. Okay, then we say it has chemical energy, and it's things like food, fuels, and batteries. Okay. Electrical energy is very useful energy because it is easily converted into other forms, quite easily, quite simply. Wherever there's a current flowing, there is electrical energy. We spoke about gravitational potential energy in a lot of detail, but just a reminder, anything above the ground has gravitational potential energy, i.e. anything that can fall, like sky jumpers, aeroplanes, and climbers. Elastic energy is also a form of potential energy. Anything stretched has elastic energy, things like rubber bands, springs, elastics, etc. We get lots of different types of energy. As you know, there are many different types. So can you remember some of them that we went through earlier? Thermal energy, light energy, sound energy, elastic, gravitational, kinetic, electrical, chemical, and nuclear. Okay, so let's take a look at different examples or sources. So if I take a look at heat energy, It flows from hot objects to colder objects. Example, radiators, heaters, and fires. Kinetic energy, which is movement energy. Examples are anything that moves. A football in midair, a Formula One car at high speed, or a cheetah, hopefully not chasing you. Nuclear, released from only nuclear reactions, the sun and all of the stars, hydrogen bombs, nuclear power plants, as well as the atomic bomb. Sound energy, anything noisy gives off sound energy, like your vocal cords, speakers and instruments, and you all love that energy. You're always listening to music. And light energy, examples would be the sun, light bulbs, candles, things like that. Okay, a few more just example sources just to consolidate you, grade 7s. Chemical, anything with stored energy which can be released by a chemical reaction. Then we say it has chemical energy. I said food, fuels, and batteries. Electrical energy is very useful because it's easily converted into other forms. Gravitational potential, anything above the ground, like I said earlier, sky jumpers, airplanes, and climbers. And elastic potential, anything that is stretched, has elastic potential energy, things like rubber bands, springs, even your knickers, your elastics in your underwear. Those are all examples of elastic potential energy. So energy transfer, grade 7, is when energy can be changed from one form to another. Okay, this is called an energy transfer. Example, chemical energy in food is converted to thermal energy and kinetic energy by our bodies. Now, I know I've explained this in previous lessons, but it's leading up to energy systems, so it's important that we just recap this. Okay? Gravitational potential energy in a ball is converted to kinetic energy when it falls to the ground. So, what other energy transfers can you think of? Let's just do a quick example of Homer Simpson, and he's eating, and think about what happens. Yes, there's chemical energy here, there's sound energy, there's heat energy, and yes, there is movement. Okay, the food he eats converted to the sound of him eating and him speaking, heat from his body temperature, and his ability to move and walk. Kinetic. So the law of conservation of energy now states that energy cannot be created or destroyed. It can only be transferred from one part of the system to other parts. This means, yes, that we keep recycling all the energy in the universe all the time. So, scientific laws and theories are not set in stone. They are just the best explanation for how the world works based on the information that we have. Scientific knowledge is constantly growing and changing as new discoveries are made. So we need to remember that it can change. So let's look at energy systems now. So energy systems is energy that is transferred within different systems to show that energy is conserved. Okay, there are many different types of systems that we can look at to see how energy is transferred through these systems. So let's start with what a system is. A system is made up of different parts that work together or affect each other. Now let's look at some more examples of how energy is transferred within these systems. So mechanical systems, this is a system this system is one which is based on mechanical principles, and the different parts interact in a mechanism. A mechanical system usually involves movement of some kind, a force, a push, a pull. It is often a group of simple machines working together. So, if you look over here, here's a very good example of a pulley and a rope system. such as at a construction site where the builders want to lift heavy objects up to a higher floor. The construction worker will pull on the rope which goes up over a pulley and it lifts the heavy object much higher. Okay, that is an example of a mechanical system. Another good example that you know is you swinging in the park on the swings. Okay, you are part of a mechanical system. When you are at the top of the swing's arc, you in the swing have potential energy, remember, because the earth is pulling you and you are going to start moving down. The potential energy becomes kinetic energy as you swing through the arc, and that is also a mechanical system. A thermal system, obviously you guessed it right, yes, a heat system. Did you know that the particles that make up a substance or an object, such as atoms or molecules, also have kinetic energy? Particles which have more kinetic energy will move faster than particles which have less kinetic energy. So when the particles are moving very fast, we feel the substance and we say, oh, that's hot. This is because the temperature of a substance depends on the kinetic energy of the particles. The thermal energy can be transferred from one object to another in a thermal system. When thermal energy is transferred, this is called heat, and we look at that in a lot more detail in the next few lessons going forward. So thermal energy, just a lovely little way to explain it to you. It is heat energy. Okay, so we have very excited hot atoms. Those are atoms and molecules who are excited and show rapid movement. And then we have a laid back cool atom. This is a cooler objects, molecules and atoms, and they show way less movement. Okay. So I love using this as an example, and everyone always giggles, and this is for when you get older. But thermal energy in a system is transferred always from the hotter object to the cooler object, grade 7s. So always choose who you hold hands with carefully, as you always want your boyfriend or girlfriend to have warmer hands than you, especially in winter, because then they transfer their warm heat from their hands to you, and you basically suck up all their heat energy and you stay nice and warm and toasty, and they actually then equalize to the same temperature as you. But we will get that, go into more detail with that later on. So an electrical system is when energy in a battery is used to power an electronic device. Chemical energy from the battery is transformed into electrical energy which moves along wires. It could be in this form of sound, it could be in the form of thermal heat energy and mechanical energy for your car moving, or even light energy. Okay. So in a simple diagram, an energy flow diagram, you always have an input energy, you have a process, and then you have a output. So for example, the input energy would be the chemical energy in the battery, transferred to the electrons in the wires, and whatever electrical device you were using, whether it was a fan in the form of movement giving cool air, or a radio in the form of sound, that is how an energy flow diagram works. Your input, your process, and then your output. That is a system diagram. Another example of a system is a biological system, and this is exactly how you work, grade 7s. So when an animal eats the plant, it uses the potential energy in the food which is released during the process of respiration. This is then used by the animal to move and for all of its processes. Remember its life processes, the 7 life processes go way back to Mrs. Nerg, okay? So the potential energy in the food which the animal eats, okay, is transferred to kinetic energy. And energy has been transferred from the sun, yes, remember, photosynthesis, otherwise there would be no plants, to the plant, to the animal. And here we have an impala eating the grass. It stores the energy in its muscles, and when the impala runs, the stored energy becomes kinetic energy. And then just another example of an energy flow diagram for you. We have two girls playing tennis. So the tennis player's arm and racket have potential energy as they are raised. As the girl, or it's one girl, not two girls, swings her arm, this potential energy is transferred to the tennis racket as kinetic energy. The tennis racket then transfers the energy to the ball as kinetic energy, which enables the ball to move through the air. And if I had to show this in an energy flow diagram, this is what it would look like. So the potential energy, the input energy, is the raised arm and the racket, transferred to kinetic energy in the girl's arm as she swings, transferred to kinetic energy in the tennis racket. That energy is then transferred to kinetic energy in the tennis ball. The input, the process, the output. So if we look over here, just a few more examples. For example, lighting a candle is chemical energy at the start, okay? At the end, we have lots of heat coming from the candle, but we are transferring light, okay? A battery-operated torch, chemical energy from the batteries at the start. At the end, we have thermal energy as the torch gets warmer, but the transfer is light energy. A toy car rolling down a ramp, the energy stored at the start is gravitational potential energy. At the end, we have kinetic energy as the car is moving, but it also transfers sound energy as we hear the car. A pendulum, we start with gravitational potential energy. The energy stored at the end is kinetic or kinetic. It moves, and this transfer is mechanical. Okay, right. Are you understanding the different systems? I hope so. A hairdryer, chemical, obviously from the fuel burning at the power station coming into our mains electricity, the coal burning. This is kinetic energy, okay? Movement energy from the hairdryer inside the little motor that turns, and it is also transferring energy in the form of sound energy as we hear it. A simple circuit, we all know, chemical energy from the batteries. Energy at the end, we do have thermal energy, heat energy, because obviously the wires are heating up, the light bulb's heating up, or whatever we have in our circuit, and the transfer is electrical energy in the system. Okay, grade 7s, just a few everyday examples. So let's look at some questions now. What is the main energy transfer taking place in a solar-powered calculator? Solar-powered, the main energy transfer that would take place there would be light. Well done. What are the energy stores involved when using a camping stove? So those little gas stoves for camping. What would be the energy stores there? Yes, chemical as well as thermal. Okay, it doesn't only give off chemical energy to give us the heat. Okay, it also gives us heat energy to warm us, warm our food, or even could be used for light energy if we needed to see. And the energy stores and pathways involved with an electrical radio, you all know this one. Okay, so the energy stores are chemical at the power station if it's connected to the mains. Okay, there are also thermal forms of energy there, as well as electricity and sound transfers. Okay, what energy takes place in each device here? The transfer, look at a burning match, a portable torch, a radio, a television, a catapult, a mobile phone, and a car. Right, so basically burning match goes from chemical and heat is released as well as light. A portable torch, chemical from the batteries to heat again and light. Okay. Radio, electrical to sound and heat. Television, electrical to sound and light, and also gives off a bit of heat. Catapult, remember our human catapult? Elastic to kinetic and heat. A mobile phone is chemical from the batteries in the mobile phone to sound. Car, chemical to kinetic, and also gives off sound and heat. So there are constant energy transfers. And like I said earlier, in all of these transfers here that happened, energy is not lost. We need to remember this. It is conserved. The law of conservation of energy states energy cannot be created or destroyed. It simply changes from one form to another or is transferred from one object to another. Very important that you remember that. And just to end off and put a smile on your faces, especially if I repeated myself quite a bit, I'm sorry. It's just about making sure you understand and consolidating. And just remember, we're dealing with a very wide audience here. Some of you might know everything already. Some of you might only be watching this or learning about energy transfers for the first time. So we have to meet everybody's needs through one video. So I hope you all understand that, grade 7s, and I didn't bore you too much. And for those of you who are watching for the first time, I hope you learned something new. So basically, if you look at my cartoons, look, I know I said energy saving, but this is ridiculous. A little hamster wheel and the dog and the guys watching TV. In the 1960s, remember, the answer, my friend, is blowing in the wind. Now in 2020, yes, it is. It literally is. We use wind energy, okay, to get electrical energy. And then this is pretty cool, huh? I can change my wireless device, charge my wireless device anytime, anywhere. And thank you and credit to Cartoon Stock for these lovely little cartoons that we get to enjoy every now and again. So grade 7s, my apologies. Sorry. Been recording too many lessons today. Thank you for watching. I hope you learned something new. I look forward to seeing you again later on in the week. Have a great afternoon. Please download your homework sheets, get busy, and enjoy. Take care, grade 7s.